Hey guys, this is Ulrich from Nostalgic Mathematics. In this video, I'm going to show you how to ace the golden limit challenge. If you're new here, do not forget to subscribe. We are given this sequence AN. The first thing to do here is to figure out how this sequence operates. So let's imagine first that AN is A over B. So by definition of this sequence, AN plus 1 going to be 1 over 1 plus A over B. And then multiplying both numerator and denominator by B, we get B over A plus B. It is very interesting what we see here. It means that to get the current term of the sequence, we use the previous term denominator as the numerator, and we just have to add both the numerator and denominator of the previous term to have the denominator of the current term. So with this idea, we can identify the first terms of this sequence. Since A1, which is 1, is also 1 over 1, to get A2, we just pick up this denominator as numerator 1. We add both numbers, 1 plus 1, 2, and that's the second term of the sequence. To have the third one, we just take 2 as numerator, and we add both numbers, 1 plus 2, 3. So this is going to be 3 here, 3 plus 2, and here 5, and then 5 plus 3, and so on. Now, another striking point, we see a sequence appearing here, 1, 1, 2, 3, 5. But this sequence has a special trait because of this formula. You see that 2 is 1 plus 1, 3 is 1 plus 2, 5 is 2 plus 3. Actually, to get the current term of this sequence, we just have to add the two previous terms of the same sequence. So we know how to characterize this sequence. So Fn plus 2 is Fn plus 1 plus Fn, and F1 is F2 is 1. This is called the Fibonacci sequence, for those who know this sequence. Now, let's have another look on this sequence. For instance, you take the first term, 1 over 1, is the first term here over the second term. 1 over 2 is the first term here over, is the second term here over the third one. 2 over 3 is the third term here over the fourth term. So intuitively, we may want to prove that AN is Fn over Fn plus 1, but we can do it by induction. Imagine that AN is Fn over Fn plus 1. Using this formula, AN plus 1 going to be Fn plus 1 over Fn plus Fn plus 1. But by definition of the sequence Fn, this is Fn plus 2. And we have proved our claim by induction. Now, it is interesting because A1 multiplied by A2 multiplied by ... multiplied by AN minus 1 is a telescopic product. So we know how this works. So we're going to have at the end the first numerator over the last denominator. So we're going to have F1 over Fn. But since F1 is 1, this is 1 over Fn. And we can deduce that this nth root is the nth root of Fn. Now, as I said, Fn is the Fibonacci sequence. And we know that Fn can be written as follows. I hope this is okay for everybody. But if you don't know it, do not panic. I'm going to show you how to get this outcome. Now, look at this linear recurrence relation. We know that the characteristic polynomial of this sequence is t squared minus t minus 1. So it is easy to compute the roots of this polynomial, which are alpha and beta. Alpha here is the golden number. So we know that Fn we write as this, a constant A multiplied by alpha to the n plus beta, plus b rather, multiplied by beta to the n. So we need to find A and B, but you just have to solve this equation, this system, F1 equals 1 and F2 equals 1, and then you can find A is 1 over the square root of 5 and B is minus 1 over the square root of 5. So Fn we write as this, but you can see that this formula is the same as that whole formula. But we will keep going with these notations, alpha and beta, to be concise in our presentation. So here, we factor to have alpha to the n here and to have this other term. So we can rewrite this using the exponential function as follow. So the nth root of fn is just alpha. You know that you divide every exponent by n, so here we have 1 over n. But one interesting thing is that this absolute value is less to 1, because the absolute value of beta is minus beta, which is, so, this ratio will become the square root of 5 minus 1 over the square root of 5 plus 1, so this is less than 1. Now you see that it is very straightforward now to compute this limit, because this is going to 0, and we know that the limit of 1 over n log of 1 of the square root of 5 is 0. So this is going to e to 0, which is 1. So this limit is alpha. And then the golden limit is alpha, which is the golden number 1 plus the square root of 5 over 2. And we are done. Thank you for your attention. Again, do not forget to subscribe, like, share, and post your comments. Bye.